In this example, we will solve an assorted mix of questions. In part A, the graph of y equals the base b logarithm of x passes through the point 8, 2. What is the value of b? Begin with y equals the base b logarithm of x. Plug the x and y values into the function and solve for b. Reverse the equation so we can use the 7 rule. Converting to exponential form gives b squared equals 8. We only require the positive square root since the negative case would make the logarithm undefined. Rewrite 8 as 4 times 2 so we can simplify the radical. The answer is 2 root 2. In part B, what are the x and y intercepts of y equals the base 2 logarithm of x plus 4? We'll begin by finding the x-intercept, which occurs when y equals 0. Plug in 0 for y. Convert to exponential form. Two to the power of 0 equals 1. Isolate x to get negative 3. The x-intercept occurs at the point negative 3, 0. Now we'll find the y-intercept, which occurs at x equals 0. Plug in 0 for x. This gives us y equals the base 2 logarithm of 4. Evaluate the logarithm to get 2. The y-intercept occurs at the point 0, 2. If we graph the function, we can see the x and y intercepts. In part C, what is the equation of the asymptote for y equals a base 3 logarithm of 3x minus 8? Factor 3 out of the binomial. The graph of the logarithm is shifted right by 8 over 3 units, so the asymptote is x equals 8 over 3. In part D, the point 27, 3 lies on the graph of y equals the base b logarithm of x. If the point 4k exists on the graph of y equals b to the power of x, then what is the value of k? Begin with y equals the base b logarithm of x. Plug in 27 for x and 3 for y. Reorder the equation so we can use the 7 rule. Converting to exponential form, we get b cubed equals 27. Raise each side to the reciprocal power so we can get b by itself. The cube root of 27 equals 3. Now write y equals b to the power of x. Plug in b equals 3. Now plug in 4 for x and k for y. The value of k is 81. If we bring up the graphs, we can see both points. In part E, what is the domain of f of x equals the base x logarithm of 6 minus x? Use change of base to write the logarithm as a fraction. The numerator is defined for 0 is less than x, which is less than 6, and the denominator is defined for x is greater than 0, where x cannot equal 1. Combining these results, we get the domain 0 is less than x, which is less than 6, with the additional restriction of x cannot equal 1 because of the log x in the denominator.